finding the inverse of an equation corresponds to section 6.4 of your book, and we'll do two examples together. First, we'll do the way we did in the class activity. So if you have a function f of x equals 2x minus 1, if we were to list the steps, okay, this is our original function, f of x equals 2x minus 1. What's happening here is that following PEMDAS, what you're doing is you're taking a number, you're multiplying by 2, and you're subtracting 1. So if you wrote that, you are multiplying by 2, and then you are subtracting 1, if I write out what the steps are. So to find the inverse, what you want to do is go the opposite direction and do the opposite. Opposite direction and do the opposite. So we know that our answer for the inverse, and what's also really important is the notation, f inverse of x. This is not a negative exponent. It has nothing to do with that, but unfortunately it looks like an exponent, but it's not. It's just notation, and that's the word for that is inverse. That's all it means. It means undo what you did before. So to undo what we did before, we follow these steps, we go in the opposite direction. Instead of subtracting 1, we add 1. So you take x, you add 1. Instead of multiplying by 2, you divide by 2. Good. So that's the inverse, and we know that that's what it is using our intuition, common sense, reasoning. Now there's another way to do this. So method 2, that was method 1. Method 1. Method 1. Here's method 2. And sometimes when they get more complex, we want to use method 2. And it is to, what you first do is you switch x and y. Switch x and y. You literally swap them. Let me just make this a little bit bigger. Switch x and y, and then solve for y. Solve for y. And this will achieve the same end result. But fortunately, you understand the meaning of what you're doing. So let's try this method 2. Our original function, we first need to write the original as y equals 2x minus 1. Okay, that's the same thing. You guys know that f of x and y mean the same thing. Okay, so that's just the original. Now you switch x and y. Literally replace the y with an x and replace the x with a y. Okay, and then you just need to solve for y, meaning get y alone. This is algebra 1. Get y alone. So you add 1 to each side. So 2y equals x plus 1. And then you divide both sides by 2. So y equals x plus 1 over 2. And matching up with the answer that we knew it was, you see how it is the same thing, but you should write your final answer as instead of y, we don't want to write y equals because we would get confused with the original. This was the original, and this is the inverse. So we don't want to use y again, so it's better to use inverse notation. F inverse of x equals x plus 1 over 2. And of course, if you want to graph, this is just a linear equation. The slope is a half and the y-intercept is a half. But so that's the complete example there. Let's do one more, and we'll just do method 2 only. So example 2. Let's try f of x equals negative 3x plus 1. So following the steps, the original is y equals negative 3x plus 1. This is the original. Then we switch x and y, so x equals negative 3y plus 1. Solve for y, subtract 1 from each side, and divide by negative 3. And so the inverse is f inverse of x is x minus 1 over negative 3. But I do want to show you that if you're graphing the inverse, which we also did today, you want to be able to write this in y equals mx plus b form, so you should distribute the negative 3 to both of these. So you actually get negative 1/3 x plus 1/3. It's important to be able to write it that way to graph it. So I encourage you to write it the way the book does when you're checking your answers, but if you're graphing it, it should be like this. You would you divide each of these by negative 3, and that's what you get. This becomes plus 1/3.